Today, our main focus is on the photoelectric effect. Photoelectric effect is the process that occurs when light of a certain frequency is shown on the metal surface, causing the electrons to be emitted. These electrons are called the photoelectrons. Light exhibit the properties of a particle and wave. Light as a wave assumes that any light can deliver its energy to the electrons, causing the electrons to be emitted. Meaning that, when light is shown on the metal surface for a long time, it will have enough energy to be delivered to the electron. This will cause the electron to leave the metal surface. And if you increase the intensity of light, the photoelectric emission will occur sooner. The wave theory fails to explain why electrons are only emitted when light of a particular frequency is used, and why increasing the intensity causes more electrons to be emitted. The quantum theory or the particle theory explains light as a particle. Light is carried by photons. What are photons? These are packets of light. If photons carry light, it means they also carry the energy of light. What is this energy of light or energy carried by photon? This energy, it was found to be equal to h times f, where h is Planck's constant and f is frequency of light. Energy is directly proportional to the frequency of light. This means that an increase in energy will result in increase in frequency, but shorter wavelength. In order for the electrons to be emitted, there are rules governing the whole process. Each photon only interact with one electron. The photon deliver its energy to the electron and disappear. This is because a photon is a packet of pure energy. The light must have a frequency greater than a threshold frequency, whereby a threshold frequency is a minimum frequency required for an electron to be emitted. How come a more intense or brighter light such as red light does not cause emission of an electron? For an electron to be emitted, the energy of light has to be greater than the minimum energy required to emit an electron. This minimum energy is what we call the work function. Each metal surface has its own specific work function. When this happens, the electron gain extra energy to leave the metal surface. The extra energy gained by the electron to leave the metal surface is what we call the kinetic energy. The energy supplied by the photon to the electron, it was found to equal to the energy used by the electron to leave the metal surface. This is the conservation of energy principle. Energy of a photon equals work function plus kinetic energy, which is the extra energy gained by the electron. Thanks for watching.